Okay, so good day everyone. Today we'll be discussing another past board exam problem taken from the May 2018 CE board exam. So the problem goes, um, a vertical triangular gate 0.9 meter high have its 2 meter base flushed with the water surface. Question number 1. We need to determine the total force acting on one side of the gate. Question number 2. The location of center of pressure. And question number 3 is the eccentricity in meters. So what is the solution for this type of problem? So first things first, we need to illustrate our problem. So it states that a vertical triangular gate 0.9 meter high have its base 2 meter have its 2 meter base flushed with the water surface. So meaning this is an inverted triangle. So with its base 2 meter base flushed with the water surface. So this is the water surface. So for ease of our solution, we also need to put the properties of the gate. First is the center of gravity. Next is the center of pressure where our hydrostatic force acts. So if we can reflect that one here, this is the center of gravity and this is the center of pressure. Now, it states in question number 1, we need to determine the total force acting on one side of the gate. Of course, if our uh, gate is submerged in a fluid, it will have a force that is the hydrostatic force. So what is the value of that? So for question number 1, our solution, the hydrostatic force F has a formula of unit weight barred H times the area. Now, the unit weight, we will consider water as our fluid since it is stated in the problem. So, unit weight of water is 9.81 kilonewton per cubic meter. Now, what about our barred H? Our barred H is, again, the distance from a center of gravity to the water surface. This is our barred H. Now, what is the value for our barred H? For a triangle, the distance of center of gravity from the base is 2/3 of, no, this is 1/3 of its height. Well, from the tip, that is 2/3. I will repeat for a triangle, the location of the center of gravity is 1/3 from the base and 2/3 from the tip. So since our barred H is reckoned from the base of our triangle, so we can say that barred H is 1/3 of our height, which is 0.9. 1/3 of 0.9 or 0.3 meter. The area, of course, this is a triangle. 1/2 base to height 0.9. So our total hydrostatic force acting on one side of the gate is zero point 0.9 times zero point 0.3 times 1/2 base times height. That is 2.6487 kilonewton or 2.65 kilonewton. So for our question number 1, that is letter A. So for our question number 2, we need to determine the location of the center of pressure um, from the top in meters. Take note, this is recon from the top. So we can say that um, our solution for that is this one. This is the location of the center of pressure from the top. So that is equal to barred h plus the eccentricity. Now, we still do not have the eccentricity, but that is what we are looking for in question number 3. So we'll just proceed with question number 3. The eccentricity has a formula of, recall, the eccentricity has a formula of moment of inertia times area times barred y. So again, the barred y is equal to barred h for um, um, barred h if not inclined. So actually, if our gate is inclined, it will look like this one. Let's say we have our water surface here, and we have our center of gravity. Our barred h is the vertical distance from the water surface to the center of gravity, whereas our barred y is the perpendicular distance from CG to the water surface. Now, since again this is not in an inclined gate, we can say that barred y is equal to barred h. Recall also that the moment of inertia for a triangle is equal to BD cube over 36, or base times the depth cube over 36. So base is 2 times 0.9 height cube over 36 over 1 half base, that is 2 times 0.9 times the barred y, which is equal to barred h, which is equal to 0.3. So our eccentricity therefore is equal to 2 times zero point 0.9 cube over 36 times zero point 1 half, 2 times zero point 0.9 times zero point 0.3. So our eccentricity is 0.15 meters. So for part 3, that is letter C. Now for question number 2, going back, we can say that y is, or the distance from of center of pressure from the top is barred h, or 0.3, plus the eccentricity, which is 0.15. So y is equal to 0.45 meter. From the choices, it is letter C. So that's it. You can now take a screenshot of our problem solution. Thank you very much.